Well, thank you, Nathan. Happy Friday. Hello, everybody. We're the students at United Tribes Technical College. Um, our presentation today is on water quality within the Standing Rock Sioux Reservation. Again, we're from United Tribes Technical College located in Bismarck, North Dakota. The students, myself, Marshall Smith. We also have Abraham Weasel, Skylar Albers, and Ebony Schultz, and Tanner Vio. We also like to give a shout out to our advanced intern, Kianna Stroh, and our faculty, Jessica Logan, Emily Biggane, Elisha Yellow Thunder. Okay, next slide, please. So today, we would like to address an issue that is critical for environmental justice for the Sioux Nation concerning water resources. Water is not just a fundamental human right, but also a sacred element deeply intertwined with the cultural and spiritual practices of many people. Native communities have historically faced significant challenges in accessing clean and safe water. This injustice stems from a legacy of broken treaties, displacement, and inadequate infrastructure. The Standing Rock Sioux Tribe fights against the Dakota Access Pipeline underscores the broader issue of tribal sovereignty and the right to protect sacred lands and water sources from potential environmental impacts. Next slide, please. Historical trauma refers to emotional and psychological wounds that can be passed down through generations. For the Sioux tribe, this trauma stems from the loss of land, lives, and cultural, as well as forced relocation. The environmental damage exacerbates these traumas, making it difficult for communities to advocate for and protect their health and the environment. Next slide. So that moves us into the Pixelone era. So the Pixelone era has made a profound impact on tribes living in the region. The plan's comprehensive water management plan, implemented in the 1940s, was aimed to control flooding, generate power, facilitate navigation along the Missouri. The plan was to bolster economic development and infrastructure. This led to the displacement and disruption of indigenous communities that inhabited the river basins for generations. Large dams caused the destruction of sacred sites, burial grounds, and agricultural land, forcing relocation of communities. This had a devastating effect on hunting, fishing, and gathering practices that are vital to the tribe's way of life. The tribes were locked out of meaningful consultations, and compensation. The federal government's decision process and the failure to adequately address the concerns of the affected tribes further marginalized indigenous populations. The legacy of the Pixelone era continues to shape the relationship between the U.S. government and the tribes in the Missouri River Basin. Next slide, please. And here you kind of get a little bit of a context of the tribes that were affected. So in 48, the three affected tribes of the Berthold Reservation, Cheyenne River, Standing Rock, Crow Creek, and Laurel Brule were affected by the plan. So you can see just how much land was used for this project. And it goes into South Dakota too. Next slide, please. So the legacy of displacement. Wow. The affected land, so 156,000 acres, which is roughly 90% of the land of best farmland, flooded, 80% of residents relocated, and 550 square miles of land was taken during the dam building. And so here you can see down in the right-hand corner, that is George Gillette, which is a council member of the three affiliated tribes. And you can see he's surrounded by some other members of his tribe, but mainly government personnel. And you can see he's just weeping because he knows that he's losing his land, his culture, his way of life because of the progress of the U.S. government. And so that man signing that document is Mr. Sloan. So this just goes back to that generational trauma. So next slide.
Adding on to that, talking about the importance of water. Water is life, mini we chose ani. For indigenous nations, water is the giver of life and a sacred connection to our ancestors. Whenever we make decisions, we consider the impact on the 7 generations ahead, ensuring that our descendants will have access to clean, sacred water. Maintaining a clean water supply is critical for the well-being and survival of our people and our traditions. The importance of water to indigenous nations was highlighted during the Dakota Access Pipeline when many tribes came together to protect the water from the pipeline.
Okay, next up, we're going to be talking about the research questions that we went over in this project presentation. So what we're really looking at is how climate change affected and impacted the Standing Rock Sioux tribe, which is also located in Sioux County, North Dakota. I'm going to be using those terms interchangeably, Sioux County, North Dakota, and Standing Rock Sioux tribe. We're looking at the concentrated animal feeding operations, and these are just large groups of animals that are grouped together for either it could be pigs or cattle or chickens or any type of bird that is or animal that's used in for domestic food purposes. Yeah, so then these have the habit of releasing a lot of E. coli contamination into the local water supply, and additionally, nitrates and ammonia are also used in fertilizer, and as those wash off into the river basin, those can increase the contamination of local water supplies. So we're going to be looking at those effects as well. And this was our data collection process here. If you can see, it's kind of mapped out for you. We're looking at relevant data sets, and these data sets often came from the USGS, but they came from other sources as well. We would download this data and identify the relevant parameters that we wanted to look at, and then we would just like harmonize this data with other data sources, such as cattle data from the USDA. And then we would identify significant environmental impacts to narrow that data down. So we don't want to look at the whole data. We just want to look at specific parameters of the data and including specific time and dates. This is a kind of like a sample subset of the code that we use to understand the data. You can see there's 3 stations listed there. Later on during the presentation, you're going to see a map of where these 3 stations are located at, but right now these are descriptions. The Cannonball River is located north of Standing Rock Sioux tribe, so it's right above it. And this is the parameters that we're looking at, again, ammonia, E. coli, nitrates, and phosphates. We're going to go into more into depth into those parameters later on in the presentation. And here's the cattle data that we were looking at, and this one came from the USDA and the NAS. So then the counties that we're looking at is Adams, Grant, Morton, and Sioux counties.
So when we were considering what bodies of water to look at within the Standing Rock community, we chose the Cannonball River, and to figure out basically where all of the water goes to when there's a rain event and there's agricultural runoff and manure runoff. We wanted to figure out basically what watershed that Standing Rock community and surrounding counties lied in. And so what we found is that it's going to be in the Missouri River watershed, which is been coined the Kia watershed by elders in the community. The Missouri River watershed is a sub watershed to the Mississippi River watershed and lies in the Gulf of Mexico ocean basin. And we picked Cannonball River since it provides water throughout Sioux County, and it lies actually along the northern border of Sioux County. This picture doesn't do justice depicting where the river is, but we'll show you a better one in following slides. The Cannonball River provides a stable living environment, as well as the water is used for agricultural practices from rangeland to cropland. That being said, with cattle on the land and crops on the land, it brings manure runoff and fertilizer pollutants as well in the forms of sediment, bacteria, and nutrients. This does cause downstream damage. The Cannonball River is a tributary of the Missouri River. Pollutants continue to flow into the Missouri River and contaminate the water that flows through downstream 5 more states. Okay, so on the left side, you'll see a cell of code that we used to create this map that was on the right, help with Emily. You can see in red, that's the Standing Rock Sioux Reservation, bordered in black to the north. On the North Dakota side is the 4 counties surrounding that. And also those blue triangles indicate the 3 stations that we used for our water quality data. Next, we're going to get into the water monitoring and the surveillance results that we were able to come up with. And this is one of the many graphs that we made using code. This one depicts ammonia for all 3 stations. If you see up in the right-hand corner is a legend indicating which color goes to which station. And then the dotted red line is the EPA compliance standard with the max value of 0.25 milligrams per liter. Ammonia can enter the water system through a variety of ways, such as nearby animal farming and industrial commercial processing waste. Animals do produce a very high ammonia levels in nearby water sources. Next slide.
Oh, this is me. So again, EPA, there's our base, which is the red line. And EPA recommends a 6.5 to 9.0 for fresh water in terms of water quality. We recognize that pH levels are near neutral and slightly above to basic, which is alkaline, which means the water quality is suitable for most aquatic life. The higher levels could mean that the water is becoming more alkaline due to agricultural runoff. The pH level and ammonia levels are connected as the water becomes more toxic to organisms. If the pH increases anymore, the toxicity of the ammonia will also increase, making the water more toxic to aquatic organisms in the water. And the regulations take into account both concentration levels to assess the potential toxicity and risk to aquatic life.
Next up, we're going to be going over E. coli results. So whenever we're looking at this graph, that dotted line represents the EPA compliance standard. Anything above that is non-compliance. And unfortunately, just because this is a non-point source pollution, meaning that the source contamination comes from many different sources that the EPA cannot trace down in order to go after those who are in non-compliance. A lot of this goes unpursued whenever it comes to putting others in compliance. So there's a lot of non-compliance sources in here. I think whenever I did like the math, there was like 87% non-compliance. And again, that's just because of the non-point source. It's really difficult to tell where the E. coli contamination is coming from. But what this means is that this water is not safe to swim in at certain times, most of the time. And it's not safe for any other type of recreational use.
Here we have the results for nitrate and nitrite in the water. As we know, nitrogen can enter the water after fertilization, which leaks into nearby streams and lakes like livestock manure, pet waste, wastewater, agriculture runoffs, dairy lagoons, leaking sewers, and liquid waste discharge from septic tanks. Through nitrification, nitrogen, primarily as ammonia, is converted into nitrate and nitrite. The EPA uses a formula to calculate the acceptable level of nitrate and nitrite in the water, which incorporates water temperature and pH. There's a formula for both short-term and long-term exposure limits. We don't have the limit displayed on this graph because we couldn't get the formula to work at the time we had. However, you can see that across the 3 monitoring stations, there are similar peaks in nitrate and nitrate levels.
And then lastly, another water quality measure we examined was phosphorus. Phosphorus can be found in streams from soil erosions, bank erosions, fertilizers, runoffs from urban areas, leaking septic systems, and discharges from wastewater treatment plants. On the graph, the red dotted line on the plot indicates the recommended level of phosphates in rivers. This recommended level is 0.1 milligrams per liter. The level is recommended, but there is no compliance standard for the EPA. At all three stations, there are several instances between 2013 and 2024 where phosphorus levels exceeded the recommended 0.1 milligrams per liter.
So the next few slides are going to go over the environmental and human activities in the Standing Rock community and surrounding area. This is just a snippet of a cell of code that we used to create a graph of our cattle data. What you don't see indicated in this picture is all the previous cells of code that were quite a few to get to this one and our results. It was a lot of pulling in the data, cleaning the data, a lot of trial and error, and making subsets. So here is our cattle data from 2002 to 2022. You can see the big gaps in data. That's just because the USDA only does a census of cattle every 5 years, and they just count the total heads on each operation. And you'll see blue is for Grant County, yellow is for Morton County, Sioux is green, and red is going to be Adams County. And on the y-axis is the amount of cattle heads. So over the years, there has been quite a change in the environment and has affected the vegetation. Where there was once bountiful to big and little blue stem grasses, prairie smoke and goldenrod flowers, and many other native plants that the indigenous communities relied on previously. They used to thrive here. They have now been whittled down in numbers and replaced with non-native invasive species of vegetation, such as yellow sweet clover, leafy spurge, Kentucky bluegrass, as well as absinthe woodworm and many others, as well as cropland too. The change in vegetation is the result of climate change and human activity. There has been an increase in temperature in North Dakota by over 2 degrees Fahrenheit in the last century along with an increase in rainfall. These changes are affecting the landscape and the inhabitants that live here. Invasive plant species that have better adaptability are outcompeting native species that were once well adapted to previous cooler and less wet climate. The increase in various human activity has also had a negative impact on the plant life on the prairies. Grazing cattle is known to compacted soil, and presents multiple barriers for the vegetation on the landscape. There's less air in between soil particles, which increases agriculture runoff and manure runoff. During a rain event, the water isn't able to permeate the soil as well as a remnant prairie or intact prairie. This means there's less available water for the plants on the landscape for their roots to take up. Vegetation that is indigenous to the prairies have deeper root systems because of glacial till that that did occur on the lands in the earliest day. Now that there's that soil compaction, non-native species that have shorter, shallow root systems are taking up the little available water that does percolate into the ground. Also, some of the nutrients like phosphorus and nitrogen that typically would be filtered in a healthy soil are contributing to agriculture runoff. According to the North Dakota Department of Environmental Quality, phosphorus loads have increased almost 50% and nitrogen has increased 13% over the last 20 years. And these pictures on the right are just some of the native species of plants that are found in the area. The top one is prairie smoke, followed by goldenrod. And then the bottom one is the June. My apologies. I think it's a Juneberry. It's a type of grass. Sorry. But anyways, on the left-hand side is a picture from the USGS, and that's manure runoff. In this slide is some climate and weather events that have taken place from 1980 to 2024. You can see that the largest one by far is going to be drought, followed by flooding and wildfires.
Okay, so I'm going to go over some drought data here. A percentage of North Dakota, this is just monitoring the drought data itself. There was significant drought during 2020. And during 2013, I believe there was a flood event that I'm going to go into in the next slide. But yeah, this is just an overview of like the D0 through D4. Abnormally dry is D0, which is the yellow, and moderate drought D1. D2 is severe drought, D3 extreme drought, and D4, the darkest color on there, is exceptional droughts. So this is the climate and weather events. This was a storm that occurred in 2013, and there was quite a lot of severe storms and flooding that occurred, and there was over $1 million in damages to roads and bridges. It affected the Standing Rock Sioux Reservation. So one thing I want to mention about this, if you notice a lot of the station data that we presented to you so far, it all starts in 2013. And there was a spike in data collection on local watersheds and creeks and rivers during this time because of this flood. So that's one thing that I wanted to highlight there, and why a lot of our data seems to start at 2013.
Some more of the impactful human activities that have taken place in the area is pipeline placement. You'll see on the right-hand side is some data that we were able to find on the different types of pipelines that are placed in the area. The graph below indicates just, I believe, one of 179 pages of the environmental incident reports that have been done and taken place in North Dakota.
So following impactful human activities, the most well-known example of this is the Dakota Access Pipeline. The Dakota Access Pipeline, or the Biggane pipeline, is a 1,172-mile long underground pipeline in the United States that has the ability to transport up to 75,000 barrels of light sweet crude oil per day. The image on the left was taken during construction of the pipeline, and the map on the right shows the initial pipeline route north of Bismarck. However, this was shifted south of Bismarck due to concerns for water quality and placed just north of Standing Rock Reservation, where the Cannonball River meets the Missouri River. And here's a timeline of the Dakota Access Pipeline and the construction and everything. So starting with 2014 June, Energy Transfer Partners announces plans for the Dakota Access Pipeline. 2015 April, the pipeline route is proposed passing near the Standing Rock Sioux Reservation, raising concerns about potential impacts on water sources and sacred lands. In 2016 in April, protests begin at the Standing Rock Sioux Reservation. Then in July, U.S. Army Corps of Engineers grants permits for the pipeline. August, Standing Rock Sioux Tribe files a lawsuit against the U.S. Army Corps of Engineers, arguing that the pipeline threatens their water supply and sacred sites. September, clashes between North Dakota law enforcement, private security, and protesters, resulting in hundreds of arrests. The U.S. Army Corps of Engineers temporarily halts construction near Lake Oahe. November, law enforcement clashes with protesters. 2017, in January, Trump signs an executive order to expedite the approval process for the Dakota Access Pipeline and the Keystone XL pipeline, and by February, construction continued, bypassing further environmental review. And then in March, construction of the pipeline is completed and oil begins to flow in May. So here's a map showing the full length of the Dakota Access Pipeline that we coded with the help of Nate. The pipeline extends through both North and South Dakota and could be impacting several water sources along the way. So our contributing limitations. Some limitations that we encountered during our project included the data found through North Dakota Department of Environmental Equality or Environmental Quality had inconsistent data in terms of length and type of data recorded, making analysis challenging. The data found through South Dakota Department of Environmental Quality had minimal data for Standing Rock, with some sites only measuring limited pollutants, and the data was presented differently than North Dakota, making comparison difficult. And finally, the biggest challenge we had was data inaccessibility. The accessibility to these data sets validates the concerns our elders have.
At this time, we're going to conclude this presentation with some of our conclusions, which I know sounds for climate change. There's going to be an increased demand for land and water for resources to continue to feed our populations. Additionally, this land is going to experience climate change, and crops are not going to be able to cope with that climate change. So it's an interesting time that we're living in, and I think there's more need for awareness, but also for data collection, continued data collection, and maybe even increasing that data collection to expand it on other variables that we could also look at. Yeah, there's also a great need for funding on Standing Rock Sioux Tribe Indian Reservation, both for infrastructure to set up monitoring stations and the ability to make this information public if possible.
As we see spikes in all the monitoring stations, there's a lot of non-compliance of EPA regulations and how much nutrients are allowed in the water resources. Cattle ranching coinciding with the growing production of non-point source contamination data with increased runoff that is going to increase E. coli in water and contaminants. The cattle compact the soil and increase runoff into the water resources.
Altered human activity. Human activity through cattle operations, agriculture, pipeline placement, spills, and other things can substantially impact water quality, ultimately reducing access to clean water for current and future generations.
And we'd like to give our acknowledgments here to Nathan and Elsa, who helped us a lot. A lot of tribes, a lot of coding things they got us through, and so they were very helpful on this. Also, we'd like to give a thanks to Dr. Emily Biggane, Jessica Logan, and Elisha Yellow Thunder for their mentorship and help throughout this whole project and process. To run it, Chase Alone at Standing Rock Department of Water Resources. We also like to thank CU Earth Lab, USGS, USDA, and North Dakota Department of Environmental Quality, and Kianna Stroh, of course, our events intern, and our IRCC, which is our Intertribal Research and Resources Center, for all the data and help along this way throughout this whole summer process. Thank you very much.
All right, give it up for United Tribes, everybody. Applause in the chat. React how you can. Great job, United Tribes, on pulling all that together. I know that we had a couple questions in the chat, I think from Nick, maybe up at OLC. Professor Klein, if you wanted to turn your mic on, or if you had a question that you wanted to ask, and then we've got a couple minutes for anybody else that might like to ask a question too.
Sure. Yeah. Thanks. Great job, guys. And I appreciate all the work that you put into this summer and your mentors. And this is really cool. So, you got a lot that it's a lot of good info and work you've done. I guess just to keep it brief, my suggestion was going to be, and you might have pulled some of this data, but it would be really useful to have the discharge. Like, so you've graphed the concentrations. So how much nitrate or ammonia is in a volume of water, but how much water is coming through the river. So there should be USGS gauging stations along the river. And, when you see those little spikes in your concentrations, Is that like in the springtime when the snow is melting? That would be my guess. Is a lot of this is you have a big storm, or you have the spring snow melt, and then you have this pulse of contaminants that are in the river. And it would be really interesting to graph the actual amount of water that's going through the river at the same time. That might kind of help tell that story. So that was my main suggestion. Great job, guys.
Thank you for the feedback on that. That's actually really interesting to think about, and definitely take it up going in the future.
Hi, yes, I apologize. I've got a baby that I'm managing too on the side of things. I have kept my camera off, but yes, Nick, that's a great point. Our AI, Kianna, actually pulled some of that data. We just didn't get a chance to put it together. But yes, our thoughts are along those same lines. Just especially with where we're coming from with snow melt being a huge challenge here. And so, you know, taking that into consideration too. So.
Awesome, Emily. Thank you. And if you didn't catch that, that was Hank on Emily's hip there. He's the next generation of environmental data scientists. And thank you, Nick, for the great feedback and comment. Anybody else have anything that they want to add or ask of UTTC before we hand it over to our friends at Metro State? Megan, you've got your hand up. Go ahead, Megan.
Yeah, I was just wondering if any contaminants have been linked to the pipelines as of yet.
Okay, students, who wants to take that one? We've talked about this.
Hey, I know it's bound to happen, you know, that pipeline. I protested that pipeline too. It was just awful.
So we were looking and unfortunately the things that we would expect to be associated with a pipeline leakage are not being measured at these sites. And so it's not, it goes back to data inaccessibility, is we don't actually have that data to be able to answer that question, which is really unfortunate.
Ah, interesting. Thank you.
Great question, Megan. I just want to throw in there again, I put this in the chat, but I'll say it again. That map that you put up that had Standing Rock overlaid on the state boundaries with the rivers and then the river gauge sites, also with all like the labels and everything. That was a really good looking map, you guys. And no secret, I'm kind of I'm a little biased. I love maps. I love maps made in Python. Some folks don't agree with me. But I was really impressed to see that. And so great job with that, everybody. Just want to make sure I don't miss anything in the chat here. You guys are getting some great comments in the chat. So make sure that you check that out again. Let's give United Tribes one more round of applause. Great job, everybody. Thank you again. Thanks to Emily and Elisha and Jess and Kianna for all the help. Congratulations to Kianna too. She's not here today, but she's getting married this weekend. So if she goes back to watch this recording, congratulations, Kianna. Okay. All right. I'm going to stop talking now.